So if I show you, see, there are two strings, text and pattern, and LP and LT are length of pattern and length of text. So what I'm doing here, I'm reading T, and after that I'm using getLine function to read the whole line into a single string. So I'm reading text and pattern. Now length of pattern is pattern dot size, and length of text is equals to text dot size. So if you see here, how does this algorithm work is, you see, the area that you need to match, the visible world that you need to match, can be categorized by simply two pointers, the starting and the end points, right? So that is what we are going to use. Will be using L and R. L will be the starting point of the visible world, and R would be the ending point of the visible world, basically the current visible world. For this scenario right here, L would be 1 and R would be 3, right? When you start, L is equals to 0 and R is equals to pattern dot length minus 1, right? So that is why when you are starting, L is equals to 0 and R is equals to length of pattern minus 1, because it would have been 0 to 2, right, when you started. After that, what you do, till R is less than length of text, right, you keep moving on towards right till your R reaches length of text minus 1, right? So that is why we are moving only till R is less than uh, length of text, and after each iteration we'll be incrementing the whole visible word. We'll be moving this patterns towards right. Basically your L and the R pointer would increment by 1. Initially it were 0 to 2. When your window moves towards right, the L and R would be 1 2 3, right? So after each iteration you are incrementing L and R by 1, and you are checking whether uh, the visible world matches the pattern window or not. If it matches, you will be printing the starting index of the visible world, right? Otherwise you would do nothing. Now this match is basically matching the set of characters from L to R to the set of characters of pattern. So what you would do, you would start from 0 to I would start from 0 to less than length of pattern that you need to search, because that many characters are there to match. Each time you would be checking whether the ith character of pattern matches L plus ith. Why L plus ith? Because when you are comparing the 0th character of pattern, you would be matching the L plus 0th character of the visible world, because with the visible world start from L, right? And that is why you are comparing the L plus ith character of text to the ith character of pattern. If any of the character does not match, we do not need to continue this for loop, we can directly return false. Otherwise, if after running this whole for loop, basically comparing all of the character, if nothing matches, I mean there is not a single mismatch, we can finally return true. If I show you by running the same example here, so suppose we have these many test cases. So this is cabbage uses cab, and this is your text and this is pattern. So you see at position 0 and 13 cab is matching. I'll be providing this this code with you, so you can compare it, you can use it for your reference to learn this algorithm. Now that we have seen the C++ implementation, it's time for time complexity. Now see, if the length of text is n and length of pattern is m, then the total number of windows to match would be n minus m plus 1, and to match a single window we are required to perform m operations, because we are running a loop from 0 to a length of pattern, right? And that is why matching one window requires this much of time. So to match these many windows you require this much of time, right? Because m times n minus m plus 1. This would be this. When you are working, when you want to find out the worst case complexity, n is very large as compared to m. Usually what happens, it is possible that the text size is like containing million characters or more than that, and the key usually that you want to search is not that much large. Like I want to search the word hello exist in this large text or not. So usually when you are working, when you are uh, trying to find out big O notation, big O basically represents your worst case complexity. When you're trying to find out the worst case complexity, the size of m is very small as compared to n. The size of pattern is very small as compared to text in which you want to search this pattern. In that case, m times m would be smaller. Like suppose the number of characters in the text is a million, and pattern size would roughly be 10 characters long or 20 characters long. So m square is like 40 or 20. I mean, if it is 20 character long, so m square would be 400. So 400 is almost negligible if you compare it with a million, right? So these terms you can drop out. So the overall complexity would be n times m. Finally, the practice problem that you can practice is this. I'll be providing the link of this problem in the description of the video, b.search.me. So the problem is you are given a text, and you have to search whether in this text to the exist or not. If exist, print yes, otherwise no. So you don't have to print the whole position. All you have to do is print yes or no based on the existence of to the in the given text. So I'll be providing the link of this problem in the description of the video. So this was all for this lecture. Thank you guys for watching. If you have any doubt or query, you can ask me in the comment section. So thank you guys for watching, and till the next video drops, keep coding. Thank you.